Today, we'd like to show you how capabilities from Talend, Amazon Web Services, and 47Lining can make the benefits of on-demand, elastically priced big data infrastructure easily available to your teams. Talend is the global leader in big data integration software. Amazon Web Services dominates the market for on-demand elastic infrastructure and big data services. 47Lining is an AWS Advanced Consulting Partner and Talend Big Data Integration Partner. I'm Carla Cole from 47Lining. To support your sales kickoff and go-to-market, we've created this demo to make the benefits of Talend Integration Cloud and use of Amazon Web Services for data warehousing and big data crystal clear. You've likely seen descriptions of the high-level benefits of deploying big data in the cloud, including the ability to achieve data warehousing and big data insight at a fraction of the cost. In this demo, we'll walk through a specific end-to-end example, generating recommendations and offers to enhance revenue driven by a warehouse of historic consumer behavior and big data services that provide per-user predictive analytics. This is a desirable capability for just about every business and a common request to enterprise IT teams. However, the barriers to achieving it can be significant. The volume of consumer behavior data can be enormous, and its structure differs from any existing data warehouse. With traditional approaches, it could cost millions just to establish, maintain, and operate a warehouse for the required consumer behavior information, and then you'd still need to ensure dedicated capacity on Hadoop clusters to run the required predictive analytics processes. It would take months to get the required infrastructure, capabilities, and processes in place to respond to such a request from the business. Fortunately, through using the cloud with Talend and AWS, there is another way. Moving this workload to Amazon Web Services Cloud allows IT to take advantage of elastic infrastructure and big data services for both data warehousing and predictive analytics workloads. AWS's on-demand infrastructure can be commissioned in minutes whenever it's needed to perform work. When the work is complete, the infrastructure can be released, which stops the clock on payment for the infrastructure. This is called elastic pricing. You only pay for what you use. The result is that pricing tracks closely with your actual consumption, a quite different outcome from traditional systems sized to accommodate the peak load that must be supported. Elastic pricing for an on-demand infrastructure can result in substantial cost savings for both warehousing and big data analytics. Talend Data Fabric provides the capability to easily coordinate and manage such an approach, simplifying operations and speeding time to market. Let's take a closer look at the data and services flow that you'll see in the demo. We use Amazon S3 to establish a data lake that houses all consumer behavior information. This data lake stands on its own and doesn't need an active Hadoop cluster or data warehouse to reliably persist consumer behavior information. Because of this, the data lake is very cost efficient. Consumer behavior events are placed in the data lake on an ongoing basis and are organized based on time. We'll be using Amazon's Redshift data warehouse offering to commission an on-demand data warehouse to hold an active subset of the data lake so that new data can be prepared as necessary for predictive analytics processes. Periodically, say each night or every weekend or at month's close, we'll fire up a Redshift cluster. New consumer behavior events are incrementally loaded and combined as required with historic data. We use Redshift to generate the inputs required for a predictive analytics job that will run on a Hadoop cluster. We'll write those inputs directly to S3, where they will live forever. The Hadoop cluster doesn't need to exist while this work is happening. We will use Amazon's Elastic MapReduce, or EMR service, to provide a transient cluster that will run the predictive analytics job. Because the cluster pulls its input and writes its results directly to Amazon S3, it doesn't need to exist just to store data in the Hadoop file system made available in the cluster. Its only job is to perform predictive analytics work. This allows the cluster to be transient. It's commissioned on demand, and as soon as its work is done and job results are in S3, the cluster will automatically terminate. We will only pay for this cluster while predictive analytics work is occurring. Once the recommendations results are available and the cluster has terminated, Talend will transform the results and load them into Redshift from S3. We'll use Redshift to flexibly transform, publish, and generate reports from current and historic recommendations. Once this is done, Talend initiates a snapshot and terminates the Redshift cluster. We stop paying for the active warehouse until we need to load incremental events for the next period. At that point, Talend restores the Redshift cluster from the prior snapshot and kicks off the next iteration of the process. Let's have a look at this flow in Talend Studio. Cloud integration specialists from Talend and 47Lining use Talend Studio to author the detailed flows that implement on-demand elastic data warehousing and big data processes in AWS. Talend Studio provides a wide array of components for underlying AWS services like Redshift and Elastic MapReduce. In addition to modeling work on existing infrastructure, these components provide management capabilities like commissioning a transient EMR cluster or resuming a Redshift warehouse from a prior snapshot. The flow breaks down into two top-level jobs. We'll use the first job, Demo Setup, to set up the demo. We'll simulate actual usage by the business by loading historic events through December and commissioning a transient EMR cluster to generate recommendations as of that date. After loading results into Redshift and generating reports, the demo setup flows snapshots and terminates the cluster. The second job resumes a new Redshift cluster by restoring from the prior snapshot, loads incremental consumer behavior events for the specified month and year, and repeats the process. This job is run with each new analysis period, commissioning the required AWS Redshift and EMR resources on demand, producing results, then shutting down until the next period. Let's run the demo setup job to get the demo into a baseline state. While this job runs, we'll use the AWS Management Console to show you the actions that Talend is orchestrating within the customer's AWS account. The first thing the job does is commission a new Redshift cluster to act as the data warehouse. It will set up the warehouse with the required tables and load historic consumer data from the data lake in S3. Let's navigate to the Redshift console. Here we can see that Talend has initiated the creation of the Redshift data warehouse. It takes just a few minutes for the Redshift warehouse to become available. While the cluster comes up, let's have a look at the structure of consumer behavior event data in the data lake. Behavior events are organized based on time, using a year, month, day key path. This makes it easy for the warehouse to load a desired subset of the data lake just by specifying a key path prefix. Redshift loads the data in parallel from S3, so loads are extremely performant. Events for each day are partitioned into multiple objects in S3 to support this parallelism. Event data can be placed in the data lake by a loosely coupled process that consumes events from the applications that produce them. Talend can be used to flexibly implement such an ingestion. In this example, the entire history of events is already present in S3. We're back, and we can see the cluster is available. Next, Talend has initiated a parallel load of historic event data into the cluster from S3. Let's look at the load from S3 request in the Redshift query console. Redshift provides high bandwidth connectivity to S3 and moves from multiple nodes in S3 to multiple nodes in the Redshift cluster so that large subsets of the data lake can be efficiently materialized in a purpose-specific Redshift warehouse. Now that all historic data has been loaded into the warehouse, the Talend flow is moving on to generation of initial recommendations. In this example, recommendations are based on the past 6 months of historic data across all users. Talend initiates operations in Redshift to compute the required input dataset and unload it to S3 for use by our predictive analytics process. The input and output data for predictive analytics are organized using the same year-month approach so that the input and output from all predictive analytics are easily accessible. Here you can see the input data used for recommendations generation for December. It includes 6 months of retrospective consumer behavior data in the format required for predictive analytics. Let's now go to the EMR console where we can see that Talend has kicked off a transient EMR cluster to create recommendations. For this demo, we're using mature matrix factorization and recommendations algorithms from Apache Mahout, which can be pre-installed on the EMR cluster as it launches. EMR and Talend also support Spark, Hive, Pig, and other mature big data tools. Even though each EMR cluster is transient, AWS manages the history, lifecycle, and logs of each cluster. This makes it easy for IT to maintain an audit trail for transient clusters that they are no longer paying for. Talend can specify a number of steps that the transient EMR cluster should execute once it becomes available. AWS manages the execution of each step within the cluster and automatically terminates the cluster once all steps have completed. In this example, the steps include an out-of-the-box step to establish logging to S3 and 2 steps specified by Talend to perform matrix factorization and create recommendations. It takes a few minutes for the EMR job to complete. Because this is a transient cluster, the cluster can be sized to optimize the throughput of the job. For example, you can commission a 100-node cluster to make results available sooner rather than wait 10 times as long for a 10-node cluster. Because pricing is elastic, the cost is about the same for each of these cases. We'll wait for the EMR steps to finish. We're back and we can see that the EMR cluster is now terminated, and we've stopped paying for it. Let's have a look at the results in S3. We can see that EMR has produced outputs in S3 that include recommendations for all consumers. Talend has kicked off a simple transformation and reporting flow that transforms these recommendations, loads them to the Redshift warehouse, and uses Redshift to generate reports which are stored in S3. Now that those results are available, we no longer need the warehouse. Let's switch back to the Redshift console. We can see that Talend has initiated a snapshot of the cluster, including historic consumption data, and is terminating the cluster. Let's look at the snapshots. Talend will tell Redshift to use the snapshot that it just created to restore a new Redshift warehouse when it's time to process incremental consumer behavior events. In the meantime, we don't need to pay for the Redshift warehouse cluster. Now that the baseline data is in place for the demo, let's look at the recurring process to generate recommendations from incremental consumer behavior events. To kick off the process incremental job, we're going to specify January for the recommendations month. For subsequent periods, all we'd need to do is increment the month. Now let's run the job. Rather than create an empty warehouse, this job restores the Redshift warehouse from the prior snapshot that includes historic data. Let's have a look at the Redshift console. We can see that a new cluster is being created and will be restored from the snapshot. It takes a few minutes for the cluster to be created and restored. We're back. Now that the Redshift warehouse has been restored, the process continues as it did before with generation and unload of input data for recommendations, commissioning of transient EMR cluster to generate recommendations, loading and reporting on recommendations results, and snapshot and termination of the warehouse. Now, let's take a look at how Talend Integration Cloud makes all these capabilities available. We've already published each of the 2 jobs that we've just shown you to the cloud. It takes just a few clicks. Now when we log into Talend Integration Cloud, we see all our jobs are available. We can configure the connection parameters to the desired AWS account to use for dynamic provisioning of on-demand, elastically priced data warehouse and big data services. To kick off the flow, all we need to do is specify its parameters, in our case, year and month for which we desire recommendations. The flows work the same way, but with all of the orchestration occurring within an environment provided by Talend Integration Cloud. The data lake in S3, Redshift Warehouse, and transient EMR clusters all reside within the customer's AWS account. That's it! We appreciate the opportunity to share this specific example with you on how your customers can benefit from the capabilities of Talend Integration Cloud, Talend Studio's rich set of AWS management components, and AWS data warehousing and big data analytics. Please feel free to reach out to 47Lining whenever you encounter customers who are interested in augmenting their on-premises environment with cloud-based data warehousing and big data services.